Hello everyone. Welcome to the course Principles and Applications of Mechatronic Systems. I'm your instructor, John Yeason. Today we look at Chapter 4 Servo Control Technology, IEC 6111313 Standard, and PLCOpen Motion Control Specification Programming. First, let's clarify the learning objectives of this lesson. Understand the importance of servo systems in industrial automation and the mainstream control architecture, and focus on mastering the advantages of PLC and servo control. Understand the significance of IEC 6111313 standard for PLC programming language specifications and common compatible manufacturers. Learn the role of PLCOpen motion control specification in intelligent manufacturing and its relationship to the IEC 6111313 standard. Master the basic structure and processing logic of motion control axes in Innovance Autoshop programming software, and master the classification and application scenarios of single-axis instructions and axis group instructions. Understand the difference between the trigger mechanisms of the enable type and the execute type in the PLCOpen specification motion instruction. 1. IEC 6111313 Standard. 1. Servo System Control Architecture and PLC Advantages. Servo system is the core control unit of modern industrial automation, and its controller selection is crucial to the accuracy, response speed and reliability of the system. At present, there are three types of mainstream control architectures: PLC, embedded system, and industrial computer plus motion board. PLC is the most widely used in industrial servo control. Because of its short development cycle, convenient maintenance, and seamless integration with HMI and SCADA systems, it can realize real-time monitoring and management of the production process. 2. Introduction to IEC 6111313 Standard. IEC 6111313 Standard is the main contents. The essence of controlling a stepper motor or servo motor is to write a controller program to control the digital I/O output. The standardization of servo interface promotes embedded development, industrial computer plus motion board development, and PLC development, all of which develop corresponding libraries or instructions for motion control. Traditional PLC programming has some problems, such as platform incompatibility and poor code reusability, which affect the software development of industrial automation control system. Therefore, the International Electrotechnical Commission, IEC, formulated the IEC 6111313 standard to standardize software development and solve the above problems. At present, PLCs from well-known manufacturers such as Siemens, Innovance, Rockwell, and Beckhoff are compatible with this standard, and they are active to make the programming language consistent with it. 3. Relationship between PLCOpen and IEC 6111313 standard. Based on the IEC 6111313 standard, the international organization PLCOpen was established to promote its application in motion control. The motion control specifications it developed have been a de facto standard acknowledged worldwide, expressed in the form of common and portable functional blocks, which are convenient for engineers to apply and adjust in different projects. Next, let's take Innovance Autoshop programming software as an example to learn more about the application of PLCOpen motion control specification in practical programming. 2. PLCOpen motion control specification programming. 1. The concept and function of motion control axis. In Innovance motion control system, the motion control object is called axis. The axis is the key bridge connecting the driver and PLC instructions. It is mainly used to control the EtherCAT bus driver that complies with the 402 protocol. It can also control local high-speed pulse output and input to achieve precise control of actuators such as motors. 2. Basic structure and processing logic of the axis. Within the PLC, the axis has its own unique basic structure and processing logic. In Figure 4.15, we can clearly see the various components of the axis and the way they relate to each other. Understanding its composition and processing logic is crucial for us to write motion control programs, because only by clearly knowing how axis works can we better use various instructions to achieve the desired motion control effect. 3. Classification and characteristics of motion control instructions. Motion control instructions are divided into two types: single-axis and axis group. Single-axis instruction is used to control the independent movement of one single motor. It is a basic functional module and is suitable for basic scenarios such as start and stop and speed regulation. Axis group instructions enable multi-axis interpolation and synchronization for complex collaborative scenarios, such as high-precision machining equipment. This lesson mainly introduces single-axis instructions. If you want to learn multi-axis instructions in depth, you can download the relevant manuals from the official website of Innovance Technology. 4. Motion command trigger mechanism. The motion instructions of the PLCOpen specification are divided into enable type and execute type according to the trigger mechanism. The enable type is a level triggering and needs to maintain enable equals true to continue to take effect. It is suitable for scenarios such as maintaining stable motor operation. The execute type is a rising edge triggering. Only one rising edge is needed to trigger a complete action. It is suitable for fast response scenarios such as starting the action immediately after the product is in place in automated production lines. This lesson focuses on IEC 6111313 standard and PLCOpen motion control specification programming. We learned about the advantages of PLC and servo system control architecture, clarified the importance of the IEC 6111313 standard in common compatible manufacturers, and learned the importance of the PLCOpen motion control specification and its close relationship with the IEC 6111313 standard. Through Innovance AutoShop programming software, we have mastered the composition and processing logic of motion control axis, as well as the characteristics and applicable scenarios of single-axis instructions and axis group instructions. We also clearly understood the two trigger mechanisms of PLCOpen standardized motion instructions. That concludes this lesson. Thank you for listening. See you next time.